Okay, Victor, do we want to start?
Am I starting?
We can start. If
Okay.
you want to kick it off, you can do.
Yeah, so welcome to the webinar. We're going to talk about subjects related to Kubernetes and especially automation, right? Probably with a bit of focus within that category of how do we scale, why do we scale things, why it might be silly to do what we're doing, and so on and so forth.
Perfect. So we are the panelists today. Victor, you already know, founder and CPO. You have a very important and interesting YouTube channel. My name is Kim. I'm the field CTO of Cast AI for the EMEA region. And I would like to kick it off to start a little bit talking about automation, Kubernetes, and the nice stuff about this. It's not a sales pitch today, so we want to focus on technology. And we are really happy if you can give us interesting questions at the end. So start a discussion about technology. First of all, we want to know from you, where are you in the journey right now? Are you already in Kubernetes, fully automated? Are you at the beginning of the journey? Do you sit here in this webinar and think about what the hell is Kubernetes? What are the guys talking about? And why do we need automation? So would be interesting if you can give us some feedback where you are, and yeah, just give you a short moment to give us these feedback. And then we can kick it off. So automation, Kubernetes, this is the typical combination which is popping up all the time if I'm speaking with clients about Kubernetes in my career. So Kubernetes is easy for sure, right? So
You're the first person who said that.
sure. I did too much stuff, too much OpenStack in my past. So this was a really, really, really heavy technology. And at the end, it was dying because it was too complex. They opened it up too much. They had this idea of anything as a service, and they had to focus on infrastructure only. By the way, we get some results of our question. So we have a wild mix about the audience. We have people, they say a tiny bit say we have no Kubernetes. I have no idea what I'm doing here. But the most part of the journey are people, they are very familiar and somewhat familiar. So hopefully we have a good discussion after this. And yeah, Victor, you raised it directly. I'm the only people that say Kubernetes is easy. What makes Kubernetes great is it's a perfect service for operating containers in a cluster. Make containers at the end orchestratable. Kubernetes is an orchestrator, but what is with all the other tasks we need? Does Kubernetes care about it? Mostly not. So if we think about all these day two operation topics, we see this ecosystem. So the Cloud Native Computing Foundation has a strong ecosystem to give us all the tooling around what we need to be successful with Kubernetes. Kubernetes is a starting point, but Kubernetes is a container orchestrator, nothing more. So we need to think about which of these nice tools we see here are the right for our journey, how to bring them together, how to make them integrated instead of having a big tool zoo deployed. And this is the first question. How do we want to handle a zoo? We have two options. For sure, we can use our CLI Ninja skills and write fancy bash scripts and these one-liner. I can remember some of my ex-colleagues 10 years ago, they had this challenge who was able to make the most complex one-liner bash commands. And I say, yeah, this is nice, but it doesn't help you.
That was cheating. If you didn't allow Perl in that competition, then
yeah. Exactly.
That was cheating, man.
Having these these big Perl one-liner, I have so many bash command line tools piped into each other. So a lot of AWK and Z and cut and grep and whatever. So if you have a lot of time and if you like it, you can do this. But at the end, we see it here. We want to use automation and we have rainbows and unicorns and all our life is easier. And what is also interesting, I'm telling these automation stories since, I don't know, 10 years. And also in these days where we are, I had the feeling, okay, automation is common. It's this is what the people want to use, but I always see the problem that, come on, people has a fear that automation kills the job. I say, guys, I never saw the situation that somebody was kicked out because there was an Ansible or a Terraform or Crossplane or whatever automation was introduced. Victor, do you see the same? Do you also see that people are in fear to
I
use
mean,
automation?
I see that fear, but there is no evidence that is warranted, right? Every single company that, at least those that I've worked with, that improved and became more efficient, let's say, ended up having the same number of people or more, but more importantly, they ended up doing more, right? So
Exactly.
it's not about doing the same amount with less people. It's about being able to do more and better.
Exactly. We are able to scale. And to be honest, what are we automating? We are automating the boring tasks, these monkey work tasks. Nobody wants to sit there and install, I don't know, 20 servers. We have automation for this. Nobody wants to patch all of our Helm components we are running in the cluster. Nobody wants to sit there and type this in a shell and update all our components. We want to have automation for this. We want to have CI/CD approaches there. To be, at the end, what you say, to be more efficient. Automate the boring stuff, free up time for the interesting part. Mostly, if I'm speaking with these classical ops guys, these are just firefighters. You're sitting there, you have these ops landscape, and it's burning everywhere. And people need to think about, okay, should I run to this fire or to that fire? And with automation, if we have all these stuff automated, it removes these monkey work. It removes these boring tasks from us. We have time to make our environment better instead of just killing the fire. So, and this is inside of Kubernetes and outside of Kubernetes. We want to use the same approaches there. It makes no sense to start with an automated approach for infrastructure and then stop it for workload or vice versa. We want to have this complete pipeline completely automated. And what is key for automation? If we start with automation, we cannot do manual changes because it ends like this. So it's always, if we have an automated setup, the journey starts in Git, pipelines pushing it out. And then sometimes people get these crazy ideas and say, I need to change something, but I don't want to put it in Git, or I have no idea how to do this. So I will fix this manually and jump on a server and do some magic there. And then what will happen? Nobody can remember that this change was done. The next upgrade will be a total disaster. And then we end up in this, my personal favorite, these 50-person conference calls. I had too much in my life, and nobody needs this. So start the journey with automation and complete this journey with automation. So this is very, very easy. If it's not in Git, it doesn't exist. GitOps. It's the next buzzword we created. So it's a good combination of these DevOps and DevSecOps and however FinOps and however we call it. Just put words together. But at the end, from a technology point of view, you need a version control system. Mostly it's Git. I'm not sure if Subversion is still existing. So we need Git, and all our stuff should be stored there. What's not in Git doesn't exist. And if we want to change anything in our environment, we have to change it there. Git describes how our landscape should look like. We describe our target, and our automation pipelines are making sure that what we defined there is deployed into reality. Keep it simple. Keep it simple as stupid is the golden rule for all our architectures we have in the IT. Make it easy. Some people has the idea to create these very complex environments. Mostly these, I want to build my castle and then I want to fight my castle. Make me important. Yeah, you can do this, but I would never agree to this. Make it simple, make it easy. I don't want to be the only guy in the company who knows how this works, because what's happened if it's down, they call me, and I don't want to be called at a Saturday in the evening or in the night. Somebody needs to do this, but it's not me. So make it easy, and never do manual changes in an automated environment. It will kill you. And then mostly also, why are we automating? For sure, on the one side, we want to lower down these monkey work, these manual tasks. We don't want to have this. And on the other side, we want to be more efficient. More efficiency could mean saving money, or will end up with saving money. We want to be more efficient there. And Kubernetes and cloud, it's a very common thing. And a lot of people start with the idea cloud is cheap, and then they realize cloud is not cheap. If you just do these classical lift and shift approaches, your cloud bill will explode, and you pay more instead of you paid before in your on-prem data center. So we need to make sure that what we are operating is cost sensitive, is cost efficient created. We need automation, and we should start using all these native tools for auto scaling our environment to use the elasticity of a cloud. That's at the end the big benefit of the cloud. It's this elasticity, and we want to use this, and we cannot use it if we have static environments. So let's kick it off. Let's see which technologies do we have to make our Kubernetes cluster more efficient. And the start of this is infrastructure, and we have to think about how does our cluster looks like, and what at the end cost money. Infrastructure, yeah, okay. VMs and network traffic, it's also a big deal. But for now, let's focus on VMs. Let's focus on bare metal. Let's focus on nodes. So I said clouds, we have the big benefit of cloud is this elasticity. But how do we use this? People starting with automation, but not doing this to the end. We have Terraform scripts in place, or Ansible, or whatever. And then they pinning a number of nodes, or pinning a size of a node. So if the cluster needs to scale, people has to go to their Terraform and say, yeah, please add 4 new nodes. Pipeline will deploy this, or they go to the console of the hyperscaler and then change the size, the number count of the nodes, and then the cloud will scale out. But this is not efficient. And Kubernetes has a very cool feature, which is there per default, which is called the cluster autoscaler. So Kubernetes has native tooling to horizontally scale our infrastructure, adding nodes if it's required to add new nodes, like new pods needs to be scheduled. Kubernetes is checking, can I place these pods somewhere? And if the Kubernetes schedule is in the situation that it's understand, okay, there are no capacity available in the cluster, so I cannot place these pods, then the Kubernetes scheduler is creating an autoscaling event so that the cluster autoscaler will create a new machine. And then this scale out, perfect. But what is vice versa? So if our application shrinks, we need a way also to remove nodes from the cluster. And for this, it's important that we have a bin packing solution. Kubernetes will never do a decision and say, we will move the pod from node 1 to node 2 to free up resources on node 1. This will not happen. Kubernetes cluster or Kubernetes scheduling is not working in that direction. So we need a component which is bin packing our workloads, a component which sits in the cluster and checks which pods can we move from one node to another node to free up nodes. So we see it here. The pods from node 2 are moving over to node 1 because there's capacity available, and then we can remove node 2 without any human interaction. That's great. This is what you have to use. If you don't have it right now, you should enable it after this talk, because this free up a lot of money, and also it free up a lot of human component, because I don't need to check my cluster in regards of the capacity management. I don't need to add and remove machines there. I don't need to move workloads manually in Kubernetes. Let Kubernetes do this for you. Just easy, just to win. And there we see there are differences in regards of efficiency. You see it here. We have these two lines. The blue line is what is provisioned, and the yellow line is what is really requested by the application. And this is where the Kubernetes cluster infrastructure autoscaler acting all different. You have open source solutions, you have Kubernetes native solutions, you have proprietary solutions or commercial solutions. And scale out is an easy approach. So scaling out is unbelievably easy for all of these infrastructure autoscaler. We need a solution which is able to fastly scale down if the workload shrinks. So we see here these two examples. On the left side, we see there is potential to be better. We see potential to optimize the bin packing solutions, and then after updating our bin packing solution, may be more efficient. We see on the right side that scale up, the lines are close together, and also if the cluster scales down, these lines are close together. That's important for being successful with infrastructure autoscaling. Something else, what is also a challenge for a lot of clients is, what is the right instance for my cluster? So, for example, we are sitting in AWS, and if I'm checking how much instance types are available there, could be a lot. So in Frankfurt, we have 502 instance types, I think, right now. And who is able to have a full picture of all these instance types? Nobody. It's not possible. So what are the people doing? People have the common instance families. We know there are M5 instances and C5 and stuff like this. And then we know we have a choice between A for AMD and I for Intel. And so the people have their standard 2, 3 families, and these families will be used for infrastructure autoscaling. That's also not efficient. You have no idea what is available in the region, and maybe other and totally different instance type it's a better match for your application in regards of what is your CPU versus memory ratio. Maybe there are instance types available, they are much better range, but you are not aware of this. So if we are selecting the wrong instance for our cluster, we will probably create a lot of overhead in our cluster, which we have to pay, resource we have to pay, but they are never used. So that makes no sense. So also there, we need an intelligent autoscaling solution, which is checking which of the available instance types are the best fit for my application. And the easiest approach is just, we need a solution who know which instance types are available in the region where we're running. And then for a scaling action, check how much resources are requested by the application, which of the instance types could be a match, and best case, what is the best price I can get? Because this helps us to make a valid decision which instance should be added to the cluster at a time. For example, if the application is just requesting 2 CPUs, why should we attach a 16-core machine? Just bring in a 2 or 4 CPU machine. That's totally fine. Can be so easy. So this basics for infrastructure. Victor, what is your experience with these instance type fight? Because it's a common issue.
I know 5 of them, and that's it.
It's enough.
I mean, it's what you said, right? Nobody really knows all the types, and most of us are just picking the few that we are familiar with. At least in my case, when I don't go crazy, it's kind of I think that, I don't know, 10 gigs per instance would be okay. Let's see which one says that it's around 10 gigs, right?
Exactly. So, and then if we realize, okay, maybe we have a problem in regards of our instance type selection process, think about what is the, let's call it, lifecycle approach we want to use. Because there are different type of instance, or how do we pay for instances in the cloud? So for sure, we have on demand. There is a list price available. And it's a pay-as-you-go model. So if we use a VM, we have to pay 100% of the price. Then the hyperscaler want to give us some goodies. There is this idea of reserved instances. Google is calling them CUTs. Azure, I'm not sure. I think it's also reserved instances. So the idea is, as a customer, I'm committing to an amount of resources where I say, this is the amount I'm pretty sure I'm using for this year. So I'm signing a contract for this, say, each month I'm using these 500 CPUs and 2 terabyte of memory. And I will be charged on this if I use it or not. They give me a discount, but at the end, if I'm just using 100 CPUs, I have to pay these 500. And then there's another cool feature of the hyperscaler. They call it Spot. And the Spot instance we see here is heavily discounted. So I'm getting an instance for just 10% of the list price. This is perfect. I want to use this for all of my applications. So is there a problem with Spot? Yes and no. So the idea of a Spot instance, at the end, it feels like a normal VM. It is a normal VM. But the hyperscaler is interested to best case have a utilization of the platform of 100%. So if the people using on-demand instances or AI instances, they have some gaps in their platform for unused resources. And the hyperscalers say, for us, it's better if we charge these space for a tiny bit of the price because 10% are better than nothing. But if the other customer comes and say, I want to use on-demand instances where the hyperscaler gets more money for, and these capacity is not available anymore, the hyperscaler has the right to kill the Spot instances. So this is what we see in Azure and in AWS. We have these 2 minutes shutdown warning. In Google, it's 30 seconds. So I'm using my Spot instance, and then at one time, the hyperscaler informs me and say, in 2 minutes, we will kill your machines. 2 minutes is not much. But this brings the question up, is Spot the right idea for each workload? Probably not. So if you want to run workloads on Spot instances, Spot can help you to run very, very cheap clusters, but the workload needs to be ready for this. We say the workload needs to tolerate the Spot interruption because it can happen all the time. So if you have stateless application which are running multiple replicas, this sounds like a good idea for Spot. So you have 3 replicas, you have an anti-affinity defined. So these 3 replicas are distributed about 3 Spot nodes. And if one of these Spot nodes will be interrupted, we have still 2 replicas running, and then another Spot instance comes up, replica will be scheduled, everything is fine. Stateful applications, maybe not the best idea. You can do this. It's depending on, at the end, where is the state. If you use local storage, that is not a good idea because it is gone after the machine is killed. If you have block storage as a service from the hyperscaler, could be okay. At the end, you need to calculate the risk. What's happened if we get a Spot interruption? What's happened if my instance goes down? Is the application okay with tolerating this, or will it cause an issue in my environment? What I see very often is if people running dev systems, if we don't have an SLA, if we can tolerate the interruption, it's unbelievable. It's unbelievable easy to just switch over the system to Spot and then say, if the instance goes down, yeah, okay, then we have to wait 2 minutes, and then then my application is recovered. So it's just a question about risk management. What can we move to Spot? What do we need to move on demand? And also, there are options for running workloads in a hybrid mode. So it must not be a black or white decision. We can use mutating admission webhooks to tweak the Kubernetes scheduler to make sure, for example, I have 3 replicas. I want to run 2 on demand and 1 on Spot. If Spot crashes, it's all fine. I still have a part running on demand. So that's the takeaway for Spot. And then something else, what is interesting for Spot, the price changed during the lifetime. This is also what a lot of people are not aware. if you book an instance for price X, in the next 24 hours, the price can be different. So if you should be aware of this, you should have pricing monitoring for this to be aware that price drifts, that an instance could be more expensive. And for our planning for on-demand, some people has the interest that systems have big uptimes. For Spot, we don't want this. In regards of this price drift, we don't want to have a Spot instance running for 2 months. I don't see a high risk that a Spot instance can run for 2 months, but at the end, in regards of the pricing, we don't want this. So that's for infrastructure. So we want to use the auto-scaling capabilities of Kubernetes. There are open source solutions, there are proprietary solutions, and then we want to use Spot where it makes sense. Think about where can we tolerate the interruption, and we have to tolerate it on the application level. Victor, something I forgot for this infrastructure Spot topic.
Yeah, I mean, I'm a bit fuzzy on that one. I have a feeling that everybody talks about dangers of Spot instances. I'm not sure that they are any significantly more dangerous than non-Spot, because a couple of cases, right? When you upgrade your nodes, so if you have workload that cannot switch from one node to another, that's a problem for Spot. But that's a problem for you upgrading the cluster. That's a problem for you deploying a new release of that something. So your pods will be moving from one node to another, no matter whether you use Spot or not Spot instances, right? The only difference is that the turnaround of your workloads in Spot instances might be higher, right? More frequent. But It's not that they are safe if it's not in Spot, and then nothing will move them from there, right? They're still moving around.
Yeah, 100%. So also there is no guarantee that an on-demand node can never crash. If the hypervisor crash at the hyperscaler, the VM is gone. If it's on demand or not, it makes no difference.
But even if it never crashes, right? You're supposed to upgrade your clusters once a quarter, right?
Yeah.
So every 3 months, it's crashing by design because you're shutting down the nodes and putting in new ones. Anyways.
Yeah. Exactly. So that's why we say, so if your application is just running in a single pod and there is no potential to have multi-replicas, maybe this is not the right idea to put it in Kubernetes. Also there, yes. Kubernetes is not the holy grail. It's not that everything needs to run in Kubernetes. There are use cases for it, and there are other use cases say, don't run it there.
Or start thinking how to actually renew your application written 50 years ago.
Yeah. Exactly. But I think a lot of our audience knows this problem. I think everybody is confronted with this. So we talked a lot about infrastructure. Let's go up to workload. Also there, if we have automation in place for infrastructure, we should have automation in place for workload. And also there, if I want to scale an application, if I scale manually a replica count of an application, you can do this. Sounds like a bad idea. So how can we, so let's check out what Kubernetes have for native solutions to make workload scaling more efficient. And there are 2 really cool features. So they called HPA and VPA, native Kubernetes features. So the first, HPA, is the horizontal pod autoscaler. So instead of going to an replica say, okay, I need 2 replicas more, let the system do this for us. It's just a definition. We say to the HPA, okay, here based on CPU load, please adjust the number of pods we have in the cluster. So we see here in this example, we have 2 pods running in the cluster. And then the HPA realized, okay, the usage goes up. Looks like we have more traffic, something like this in my application. So the HPA decide we put 2 pods. We add additional 2 pods to the system, so the load can be handled. And this is working in both directions. We have load coming. System can scale out horizontally. Load shrinks. Workload can scale down to save resources, and at the end, save money. Horizontal autoscaling, the cloud story. For this, or the other way is the vertical autoscaler. So we want to scale pods vertically, means we are adding more resources to a pod. We know, hopefully we all know, that Kubernetes resources has resource definitions for requests and limits. And for the request, we tell how much resources this application need to run. We have 1 CPU, 2 GB memory, and then the vertical pod autoscaler can see, okay, based on the usage, based on the load, we will extend this. We give it more resources. We say, okay, the pod now has a request of 2 CPUs because we need more CPU. So these are 2 native technologies Kubernetes is bringing to us. We just need to use it. We need to have to understand what we are doing there, but we have to use them to make our workload efficient. And efficient is the key here. So Cast AI did a benchmark about 4,000 clusters, and we realized at the end, 13% of the CPUs are really in use. How can this happen? On the one side, we have wrong configured infrastructure autoscaler, so selecting the wrong instance type. So we have a big bunch of headroom in the cluster, which is unused. Nobody's asking for this, but we have to pay for. On the other side, we have too high defined requests. Mostly requests are 5 times higher than the application really needs. And why is this? The problem is mostly people has no processes in place how to define requests and how to observe these requests and refine them. How does people define, including myself, how does people defining requests? I need a request. I need it for my application. Think about, yeah, should be 1 CPU. It's working. Okay, we'll never touch it. We have to unlock this problem. And so we need to think about how does requests and usage works in Kubernetes. So already said, Kubernetes is relying on requests. Kubernetes scheduler needs the request information to make valid decisions where to place a pod in the cluster. And on the other side, each autoscaling solution needs a request to make a valid instance selection to see how much resources do I need, which instance type needs to add it to the cluster. So we need to check our requests and we have to monitor our usage. You see it here, I'm requesting much more resources than I'm really using. And so we can use these data to calculate what should be a right sizing recommendation. So we need, like at the end, we need what is really used, put a little buffer on top, and this should be our new request. All the other stuff, the delta is exclusively blocked resource, which we have to pay, but the application is not consuming. That's a waste of money, and that's a waste of efficiency or bad efficiency at the end. So let's look a little bit more in detail. How does it work? If we think about, okay, starting with the VPA, how does the VPA works? We are starting with a pod. We have 1 CPU, 1.5 GB memory. We have an HPA. We have a VPA. Sorry, we have a VPA running in the cluster, and then the application got pressure. So Kubernetes is observing these metrics, VPA is observing these metrics and realize, oh, this pod gets pressure. There are a lot of usage. Coming up, VPA detects this and say, calm down, we will do this for you. So a new pod will be started with a larger request. That's important to understand. At the moment, Kubernetes has a challenge. We cannot update requests on the fly. There is a new feature available since Kubernetes, I think 1.28, but it's an alpha feature. What does it mean? For using alpha features, we need to enable a feature gate. We can do this in vanilla clusters, but we cannot do this in the public cloud. So EKS, AKS, GKE doesn't allow us to use this feature. So we have to wait until the Kubernetes community promotes this feature to beta. Then we can use this, and this helps us to not not restart a pod all the time. If we need to adjust the requests, we can do this on the fly if the node has enough capacity. Because at the end, we have to restart, we have to create a new pod, and the old will be killed. Rolling update.
But you know, what you just said, if it has enough capacity, if you do the job right, and you are not much over the capacity, the real capacity. So maybe if you're 10%, 20% over, right? That would be a great situation, not 90% or 500%, like you mentioned before.
Yeah.
That means that most of the time, VPA will not be able to resize the pod because simply there will be no enough capacity unless you over provision.
Exactly. Yeah, exactly. That's the challenge. If we can do small adjustments, but in an example like this, if we have to add 200%, it will be a restart. There is no other way to reschedule this. So at the end, the VPA works in both directions. Same story. If the VPA has the possibility to size and pod down, we can do this the same. New pod will be started. We have less than the requests, and the old one will be killed. How do we update applications in Kubernetes? Exactly like this. So this is the VPA. Let's check what is the HPA doing. Also very easy. At the end, we have a replica count and we have an HPA, and the HPA is observing the application. What is the usage of the application? I can add some rule set there. And we see here, for example, I tell my HPA, if the CPU usage is more than 60%, scale out, because then we need to handle the workload and the traffic. So the HPA detects this and will increase the replicas. So that's a big difference. VPA need to restart the pods if we want to apply a change. HPA is changing the replica count, so new pods will be added or moved. Existing pods mostly are running, so we don't have these rolling iteration in our environment. So we have the HPA, we have the VPA. So everything is awesome. Perfect. Let's enable this for all our workloads and then relax. Let the magic happen.
When you say enable, do you mean enable both of them on the same workload?
That's the challenge.
Okay.
This is very important. Kubernetes tells you in the documentation, say HPA and VPA, don't enable both of them together for the same workload. Why? Let's understand what is the problem here. So we already understood the VPA is checking what is the request versus usage and bring them closer together. So we see, coming from here, we see we are just using 40%. VPA say, there's potential to scale it down. Perfect. So we go down to the recommendation. So at the end, we have a usage of 80%. We have a good efficiency. Nice. Perfect. But on the other side, we have an HPA. And we saw the HPA want to scale out if we have 60% CPU usage. So per default, you have 80%. So that means the HPA will trigger the scale out because the HPA tried to get under 60% usage, but all our pods they are starting already have 80. So this means the HPA and VPA is happy, say it's very efficient. The HPA goes crazy because it's not able to fix it up and our costs are exploding. If you don't have a limit in, we will end up with 1 million pods. So that's the reason why we say don't run, or why Kubernetes say don't run HPA and VPA together. You can do this, but if you want to use VPA and HPA together, make sure that your settings are not conflicting. If your VPA sizing it down to 80% efficiency, the HPA needs to scale out maybe by 90%, but cannot scale by less than. So it's configuration. The configuration can be tricky. It's doable. Better solutions are have both autoscalers integrated in one engine. to have vertical and horizontal scaling in one engine, which doing the decision to make sure we are not conflicting there. On the other side, we can rely on different metrics. So let the VPA scale CPU and memory, and for horizontal, use different metrics. Use event-driven autoscaler like Keda. Scale on messages in a queue. Scale on traffic in an ingress controller. Scale on something else, but not on CPU and memory, because this will avoid you also from these clash. What I say, it's not a sales show. So there are solutions in the market which can do both of them. And last but not least, what I want to say is we talked about requests, and a lot of people have in mind, oh, wait, there are limits as well. Why do we care? And this is something what I also see on a daily basis, that people don't understand how to optimize requests and limits and what does it mean at the end. So we have this easy approach. We have these two nodes we're looking for memory. In this case, we have 1 GB request. We have 1 GB available on node A. We have 3 GB available on node B. So where does this pod fit? What does the Kubernetes scheduler say? Both nodes are possible. We can place these pod on both nodes because from a placement logic, Kubernetes doesn't care about limits. We are only looking for requests. And so we had 1 GB on both machines available, so it was a match. But request versus limit. A request is just a starting point. It's a placement logic. It's what we say, what we need to run an application. The limit allows the limit limits the maximum amount of resource the application can consume. So what happens if the application goes over the request? Because the limit allows this. For CPU, mostly we can tolerate this. CPU is elastic. So if we use a little bit more CPU as is available on the node, we get throttled, but at the end, this is working. The problem is memory. Memory is a static resource. So if the application try to consume 1 megabyte more as the request, but this megabyte is not available on the machine, Kubernetes directly kills this pod. This is what you know as the out-of-memory kill. There is no capacity, we will kill it. And the problem here is, you see, we have to avoid these big deltas between request and limit, because there is no guarantee that more as the requested resources are available on the machine. That's a problem for a lot of people, because I see configurations that people requesting 1 GB memory and set a limit to 12. I say, guys, this will never work. This is you can be lucky if this is successful, because Kubernetes will schedule this somewhere. If you have bin packing solutions in your cluster, the goal of a bin packing solution is keep your cluster as small as possible. And it's just looking for requests, not for limits. So this will not work. So be careful with the sizing of requests and limits. Think about what is a good combination, because scheduling is only working for requests, or it's relying on requests. So to summarize the story, what did we understand? Where's the waste? And at the end, where's the potential with automation can help us? We have to avoid these over-provisioning, because it makes no sense to have that big amount of resources nobody's requesting for, but we just have it because we selected the wrong instance types. We have to optimize our applications using VPAs and HPAs to optimize our application. What is the right count of replicas? What is the right amount of requests to be optimal without having this big overhead defined in all these different layers? And then at the end, think about Spot. Where can I use Spot instances? Let's benefit from this cheap Spot instance price. Make your application a real 12-factor app, tolerate interruptions, be BHA in Kubernetes. And then you will have a lot of fun with Kubernetes. So I think We are good in time, so we're done with our show. We're happy to jump on or answer questions you have. So feel free to raise your hand, to raise your question. Write it in the chat. I think we have a chat. And then let's kick it off. So there's Daniel. Daniel has it's not a question. I would say it's just a hint. He's totally right. Daniel say you can get free Kubernetes tools like Goldilocks to provide recommendations on right sizing. Resource quotas only. That's true. I already used it in the past. Victor, are you familiar with Goldilocks?
Yes, but I would go further than that. Basically, without now entering what is a good and what is a bad solution, any observability tool will give you that information, right? So if you have Prometheus, let's say, and again, I'm not saying that that's the best way to do it, but if you have Prometheus, you go and execute a query, or you show it in a Grafana dashboard, and you see where your memory is, where it was in the past, and so on and so forth. So even if you don't do any of the things that you heard today, which I'm not saying you shouldn't, right? You can just go and say, okay, what is my memory usage what was it over the past 7 days, more or less, give or take, and configure your resource requests, right? And then add 20%, 30%, something as limits, right? What I'm trying to say is that you should be looking for solutions that do that for you. But at the end of the day, there is no good excuse for being 5% off. Kind of like nobody can claim that as an excuse.
Exactly.
Even if you install like Kube, and this is definitely not a good one, but if you instead install Kubemetrics and just do kubectl top pods, you will see how much they're really using, right?
Exactly. So there are a lot of tools available. And long story short, if you don't have a solution in place, you should check one of these millions existing and bring it to your cluster, because this is a very important information. I see some other questions. There is a question, Stavros. I have one question regarding bin packing and pod movement within nodes while transferring the pod. I suppose the pod is going to termination while a new one is provisioned in the target node. So in this case, any state in the memory of the app will be lost. Is it something handled? In addition, if we are talking about stateful hosting databases into pods, how can we do this without downtime?
One thing that I feel that many people are not aware of or completely miss or forget is when you write code of your application, you need to write it in a way that it handles signals. Sig term, sig interrupt, all that stuff, right? So, and this is nothing to do with Kubernetes, nothing to do with containers. Your applications, no matter where they're running, anywhere, in any platform, need to be able to handle those signals, because wherever they are, the system, when that application is about to be killed, the system will send sig term or sig interrupt signal, and your application is going to accept it. It's going to do whatever needs to be done. Let's say finish processing existing requests and then respond back to whomever sent that signal saying, it's okay, I'm ready to die now, right? If you don't do that, Kubernetes or anything else doesn't know what to do with it. Kubernetes goes and says, I'm going to kill you. You do not respond back, and it kills you, right? And this is not even directly related with scaling or any of the topics. Kind of when you upgrade, when you really create a new release, the same thing will happen. When you upgrade this cluster, the same thing. Your pods will die, and you're in control whether those pods will die abruptly or gracefully. The choice is yours, and it depends exclusively on the code of your application.
Exactly. And to just answer this question, at the end, if you have a bin packing solution, if a pod needs to move from one node to another node, it will be killed on node A and will be started on node B. So if the application is not able to tolerate this, you will have an interruption in this situation. Like if you have single replica pods, it will be killed and started there. If we think about the second question in regards of state, handle the state in databases, for example, there you should have multi-replica databases. You have 3 pods running on 3 different nodes, and if one pod needs to be moved, the pod will be killed there, starting on another node, sync the delta, and after the delta is synced, the pod gets ready. So this is how this application should handle these interruption. And how to avoid that all of your pods going down at the same time by an eviction. There is a feature called pod disruption budgets in Kubernetes, where you can tell Kubernetes how many of your pods are allowed to be down at the same time. So Kubernetes scheduler take care that we have to evict one pod after another and have to wait until the pod is ready. So this is important also. I had this discussion yesterday with a client. They're using Solar, where Solar goes or mark the pod as ready and then start sync the delta. I say this is a bad application design. So what else do we have? There is another one. What do we have? How can we deal with Kubernetes cron jobs and stateful sets?
I think it's not, doesn't matter whether it's a stateful set or deployment, right? The question you need to ask yourself, can I run multiple replicas of that something? That's the first question, right? Because if you can run only one replica, there is nothing on earth that will save you from downtime. Sooner or later, you need to be able, if you want to be safe, you need to run multiple replicas. You need to, and those replicas need to be able, what I mentioned before, to die gracefully, right? If you do that, then hey, stateful set will work just as fine as deployment. It's more complicated to implement all that stuff because if it's a database, what Kim mentioned before, you need to share the state between all replicas and what's or not. But from the Kubernetes container perspective, they must be scaled and they must die gracefully. If you accomplish those 2 things, doesn't matter what it is.
Exactly. And in regards of jobs, mostly jobs cannot be killed because if we kill a job, a new job needs to be started. And if we think about what kind of job it is, if it's a build job which runs 2 hours, I don't want that this job will be killed after 1 hour and 55 minutes. So all the bin packing solutions has the possibility to use Kubernetes labels to tell the bin packing solution which kind of workload is allowed to be killed and which type of workload is not allowed to be killed. And jobs, for example, is the perfect example. Jobs never should be allowed per default to be evicted because it will crash the job and you will lose whatever was inside of this job. So
also, I feel it's important to understand that when a node is killed, right, there are phases in that process. And the first one is I'm not going to schedule any new workloads on that node, right? So no new jobs will be coming here, right? And then at some later moment, I'm going to kill it when it's safe, whatever the safe means, depending on how we configured and what we're running and so on and so forth, right? So there is that nothing enters anymore and it's gone, period, between those 2 phases.
Exactly. Then we have one. Would you then recommend to not use multi-dim pod autoscaler from GKE?
I haven't used it myself.
I have to say the same. I cannot give you a clear answer for this. I've never checked it out.
What is interesting but very expensive, very, very expensive, is GKE Autopilot, which doesn't work in all cases and so on and so forth. But basically what it does is that it enables you to get a node for each individual application, right? So now your applications need to be right sized, but yeah, you have a new replica of an application, it requests 2 gigabytes of memory, you get a node that can accommodate that and nothing else, right? But multidimensional pod autoscaler, haven't tried, but it looks very scary. Everything I know so far about scaling based on pods, vertical and horizontal scaling, tells me it might not be the best thing.
It's a challenge. It's a challenge. There are multiple solutions there. So if you're interested on this, check it out. Can be a lot of fun. Can be a lot of pain, but can be a lot of fun. But it's normal in technology. So what else do we have? We have, how do you feel about right-sizing off-the-shelf workloads like New Relic agents, Redis, ingress controllers, etc.?
Isn't it the same?
Yeah,
You need to find out what is the right size, and then you need to apply it. I know
exactly.
that I'm simplifying it here, but I don't see the big difference between your applications. You don't know what is the right size for your applications. You need to run it for a while to find out what it is, and then you apply those sizes. And the same thing for third party, right? They all come with, and this is a bit disappointing, to be honest. My feeling is that most of third party apps come with random sizes. Kind of, it's completely random. We just put some random number of 2 gigabytes of memory in one CPU. Nobody knows how much this needs.
Yep, agreed.
By default, just to be clear.
So also from my side, I don't see a risk to do this. At the end, each application is different. So we need to think about what is the right setting for all of these tools. At the end, HPA, VPA, all of these solution needs to be configured. It's not like enable it and forget it. This can work, but it's always depending on the application. Also, if you're running Java-based applications, you have maybe a totally different challenge in regards of this vertical scaling. But this is a story for for another hour, I think. So, what else do we have that I've already answered? Then we have a follow-up comment question. Thanks for the detailed explanation. In case pod is controlled by stateful set, you cannot have one replica and perform rolling update. And for database being used as single node, no replicas, there should not be 2 or more replicas, right? Just thinking about the database topic. So this, in general, this is a question of how do you want to have high availability in your system? If a database is relying on one pod, if this pod crash, if the node needs to be evicted for an upgrade, you always have the problem that it will be a downtime. So from an application or from an architectural point of view, components like this should be multi-replicas, having multiple pods in a stateful set to avoid these situations. We can lose pods and come back without interrupting the service.
I would go as far as to say that if you're in such a situation, I'm not sure that you're getting benefits from Kubernetes. I'm not sure that you should be running it in Kubernetes. If you want to have a database, if you have to have a database that is one replica and must be one replica and it should never go down and it cannot scale, then why Kubernetes? Just put it on a VM, run it separately. It doesn't have to be, and I feel that this is important. It's not all in solution, right? You don't have to have everything in Kubernetes, just as you don't have to have everything in Lambdas or wherever else. Just don't.
Yep, agree. And then we have, can you recommend tools that would get data from workload resources of the time and suggest new resources and limits? So like, what is our recommendation in regards of tools which can do this for you? Victor, will you take this?
I mean, let's start with Cast AI. I said it so that you don't have to say it, right?
Yeah, exactly.
I mean, Cast AI gives you that, right? In general, you need a tool that will, first and foremost, you need visibility, right? Before we start talking about automation, before we start talking about anything, you need to know what talking about sizing now, you need to know how much something consumes, right? And you need to know how much something consumes over a period of time, right? And yeah, cast AI, why not?
Okay, I think in regards of the time, maybe if we have one last question, we can answer them. Otherwise, I think we can close it for today. I don't see another question, so I would say then thank you all for your time. Thank you for attending this webinar. Thank you, Victor. Was a lot of fun.
Thank you for having me.
And then looking forward to see you next time. Then thank you
Cheers,
all.
everyone.
Cheers.